This is the SOC estimator demo. As you can see here, we have the signal generator, which will act as the input current. Currently, the signal generator is a square waveform with 0 amplitude. That feeds into this battery cell model, and you can set this parameter as the actual SOC for the battery as an initial condition. So right now that is at 0.8 or 80%. And there's also this algorithm that will try to estimate the SOC. And so what we can do is set an initial condition here, and the algorithm will work and try to meet this 80% estimation. And so to demonstrate that, I can run this MATLAB Simulink simulation for 100 seconds, and we can take a look at some graphs. So I'm going to run it right now. I'm going to go to this code right here, and I'm going to run it and see what we have. So these results show the estimated SOC reaching around 70% and stopping. This is due to the nature of the battery cell one-dimensional OCV curve that's in the Simulink simulation model. The OCV SOC curve is obtained from conditional discharge test data, which was pulled into the simulation from a lithium-ion battery. If we had a more complete curve and also some input current, we could see how different this SOC estimator would look. So let's go ahead and dive into that. So I'm going to go back into the model right now, and let's put some input current. So I'm going to set the amplitude to 1, and I'm also going to change the battery cell SOC to 0.7 so we can get a more accurate interpretation of how the SOC algorithm can meet it. I'm also going to keep the initial condition at 0.5, but I'm going to run the simulation for around 600 seconds. So let's run that, and I'm going to go back to the code. I'm going to paste this new one, set the x-axis for 600 to meet our time in seconds because we changed it in the code, and I'm going to enter this. We can see that we have a new plot. From this plot, we can see that the estimated SOC converges much better to what the actual SOC is according to the initial conditions. You can also see these minor humps that go up and down because as the current cycles throughout the square waves, it actually loses accuracy sometimes. This is because not enough factors or complexities are taken into account for this estimator, and it's actually quite simple, as you can see from the retrieved Simulink model. Nevertheless, we can see how much more accurate this is compared to what we had before, because we added an input current and we had an initial condition of less than 80%. And that is it for the demo.